Hi there, I'm Tom Field. I'm Senior Vice President of Editorial with Information Security Media Group. Delighted to welcome you to today's session entitled Cyber Threats to Oil and Natural Gas Operations. Joining me today, Casey Brooks, Principal Adversary Hunter at Dragos, joined by Michael Gardner, Senior Intelligence Technical Account Manager at Dragos. Now, before I bring the two of them onto our virtual stage, let me give you a little bit of background on our session today. Adversaries are increasingly targeting oil and natural gas and related energy industries to further political, economic, and national security goals. Their activity threatens the availability of industrial technologies and the safety of those operating them. Industrial asset owners and operators can defend against these adversaries. In this session, we will learn the full scope of threats targeting ONG infrastructure around the world and focus on why all stages of ONG operations are high-value targets for cyber attacks, major areas of concerns and actionable recommendations to address them, how OEMs, third-party vendors, and supply chains increase risk in your IT and OT networks. Finally, defensive recommendations to strengthen your ICS, OT, cybersecurity posture. A little bit of background on Information Security Media Group. We just celebrated our 16th birthday. We're a global education and intelligence firm. Our headquarters is in Princeton, New Jersey in the US. You may know us, of course, by one or more of our 34 media properties. These include Bank Info Security, Healthcare Info Security, and Data Breach Today. In all, we reach an audience of over 1 million security leaders globally. We give them a daily diet of news, analysis, research, events, and academic programs just like this one. A few notes of housekeeping. If you have any questions for our panel during the course of this session, you can submit them anytime by the chat window on your screen. Likely won't get to every question today, but for those that we can't answer here, we will get responses back to you afterwards via email. Should you encounter any technical issues while viewing today's webinar, take down that email address you see on your screen. If you write to webinars@ismg.io, we do have support staff standing by to help. Also, a reminder, today's webinar is copyrighted material. It's meant for today's session and individual study purposes only. If you'd like to use any of the information presented today, or if you're looking for customized training materials, please contact us. Delighted to introduce our sponsor today, Dragos. In a world of rising cybersecurity threats, Dragos protects the most critical infrastructure, those that provide us with the tenets of modern civilization, from increasingly capable adversaries who wish to do it harm. Devoted to codifying and sharing their in-depth industry knowledge of ICS and OT systems, Dragos arms industrial defenders around the world with the knowledge and tools to protect their systems as effectively and as efficiently as possible. Delighted to introduce our speakers as well. Again, Casey Brooks is a principal adversary hunter at Dragos. He's an experienced cybersecurity professional with a background in training, supporting enterprise-scale cybersecurity operations, utilizing cyber threat intelligence and technical operations. Michael Gardner has worked in the ICS security space for over 7 years. Again, he works for Dragos as a senior intelligence technical account manager, where he helps the customers across a variety of industry verticals mature their threat intelligence programs and operationalize ICS, OT, threat intelligence. With that, let's bring Michael and Casey onto the screen here. Gentlemen, thanks so much for being here and joining me in this conversation today.
Hey, thank you so much for having us, Tom.
Let's start the conversation here. What are some of the recent cyber threats you see targeting the oil and gas industry?
Hey, Tom. So one of the most recent and probably the most prolific that we've seen in recent years is Chernovite and Pipedream. Chernovite is the adversary that we assess to be behind the development of Pipedream, which is a toolkit of capabilities designed to target specifically Schneider Electric and Omron PLCs, as well as use specific ICS protocols to or show in-depth knowledge of ICS protocols. So some of the different threat groups that we track here at Dragos are kind of, you want to look at them as a group of dedicated, typically state-backed they kind of attempt to conduct offensive operations, and usually the purpose of these is typically espionage, along with most of the time, especially if you look at ransomware operators looking to seek monetary gain. However, when we look at the different groups targeting critical infrastructure, a lot more risk and threat is involved. And essentially, we differentiate ours is because not these adversaries that we track here at Dragos don't only go after IT assets. They're not looking to just collect espionage or to create a disruption with ransomware. They are looking to access sensitive systems, whether it is to collect operational information that they can then take back and utilize to plan future attacks, but also have the potential to create loss of life, loss of containment for ecological impacts, or other things such as loss of control, preventing owner and operators from being able to know what's going on with their critical infrastructure systems. And this really demonstrates kind of the difference between an adversary that, for all intents and purposes, usually has a very low impact when you're looking at ones that target IT, while threats that target specifically OT can have a far greater and far longer reaching impact upon organizations.
So for a little bit of history on ICS malware before we go into one of the most prevalent threats to oil and gas operations, as well as sort of the industrial landscape as a whole, here's a little bit of history on ICS malware to kind of tee us up there. So back in 2010, we had Stuxnet, which targeted Iranian nuclear enrichment facilities and was kind of the first proof of concept in the wild for us to see industrial control systems and OT actually impacted by malcode. Going throughout the years in the last decade, we've had Havocs and Black Energy. Black Energy and Crash Override were both tied to Ukrainian events carried out that caused loss of transmission of power to power systems. Back in 2017, we had Trisis, which was a fairly in-depth attack. It targeted Triconic's safety instrumented systems from Schneider Electric at an oil refinery in the Middle East. Once again, kind of moving along the lines of adversary shifting to targeting OT as a part of their operations. And most recently, we've had Indestroyer 2 redeployed, which is sort of a repackaging of Crash Override. And we've seen the Pipedream framework become discovered in the last year. Casey's going to talk a little bit about that.
All right. So one of the threat groups that we really want to highlight is Chernovite. Now, what makes Chernovite unique is not only did they develop a full suite of capabilities called Pipedream, which we'll get to here in a minute, it's kind of the intent behind these capabilities that they developed and the potential impact that these can have. The current adversary customer, basically the group that sponsored the creation and operation of this tool set, currently isn't known. But what we do know about the adversary itself, based upon how well the tools were created and other factors, is that it was professionally developed. There was a ton of resources that were actually put into designing these ICS specific capabilities. Not only that, it shows a level of adaptation where sometimes you see adversaries that will go onto GitHub and use like a proof of concept and make no changes to it. They just use ready-made code. Well, this adversary actually will go out, find these proof of concepts and actually improve them and incorporate them much more cleanly into their operations. And now one of the distinctions we like to make with Chernovite is that sometimes you look at certain groups, they're known as like access groups, where their whole job is to get in and find things and then get out. while Chernovite is what we would consider an impact group. They go in to cause a specific effect or a specific impact. And in this case, with the tooling that they have, we look at what could be their intent and the potential impact, and we look at the capabilities that enable them to basically enable a loss of safety in industrial control systems, preventing operators from controlling these ICS systems, as well as preventing I guess you would say, the ability for the systems to be interacted with. That's basic loss of availability, as well as manipulate these ICS processes for their own goals. Now, what we see here is a diamond model. Now, a diamond model is how Dragos analyzes its adversaries and its threat groups. We look at 4 specific areas, which is victimology, capability, infrastructure, and adversary, kind of details, and kind of assess the impact based upon that. And one of the unique things about Chernovite is that they focus their tool development on 2 specific sets of PLCs, Schneider Electric and Omron. They also showed that they had a good or at least functional knowledge of ICS protocols to implement those into their capabilities, as well as kind of knowing how to move within a victim environment. And it's not just like code assist is one of the things that they learned, but it's also OPC UA and other kind of tool or kind of ICS protocols that they implemented functionally into their tool set. Now, when we look at what their capabilities actually designed, it's called we call it here at Dragos Pipedream. It's also known as InController by Mandiant. And one of the things that we look at is this isn't just one very specific set of ICS device. These are several PLCs that this impacts. So we look at like Trisis, where it impacted the Triconnect safety system. That's a very specific set of equipment, while this one impacts a far larger range and incorporates a lot of different ICS protocols, as I said before. And it goes from everything of using these ICS protocols to, one, manipulate PLCs. Another is to perform reconnaissance on an ICS network with these protocols, as well as being able to use these protocols to actually access and further their reach into the network, as we see with like OPC UA. Now, when I talk about Pipedream, you would look at this as sort of a toolkit for this adversary. It's not just something when you look at like Cobalt Strike. This is more of instead of like a framework, this is kind of a toolkit where an adversary can use different pieces of this whenever it works inside of a network. So we look at like the different Pipedream components. The ICS specific ones, we would look at as what we call Evil Scholar. This is what was designed to target Schneider Electric PLCs. We look at Bad Omen. This is what was designed to interact with Omron software and PLCs. And then there's also Mousehole, which was a tool designed to interact with OPC UA and to not only perform lateral movement, but also to gain access to different OPC UA servers. Now, this adversary is also able to function within an IT network, especially a Windows-based one. They developed a specific IT or a Windows-based capability we call Dust Tunnel. It's a fully functional, fleshed out, what we call like an operational implant. It allows basically what you would say that is like known, or what advanced persistent threats or anything are known for. Like they can perform lateral movement with it. They can perform privilege escalation or any of those kinds of capabilities. And they also took, when I talked about previously, where they took a proof of concept online and improved it. Well, they did that with what we call lazy cargo, which basically just uses a driver from ASRock to, they took the proof of concept code and improved it, and then incorporated it kind of a lot better into their operations. So it shows that the adversary knows what they're doing and also can improve upon already existing capabilities. Now, when we look at Evil Scholar, it is essentially a Python framework. It can brute force Schneider Electric PLCs. It can perform denial of service against Schneider Electric PLCs and other PLCs that actually use code assist. So that's one thing to keep in mind, that some of these attacks are scalable against other PLCs, but this one was specifically designed to target Schneider Electric controllers. And they can also conduct what's called a packet of death, which essentially makes the PLC unrecoverable. And they can actually proxy traffic through the PLC to other PLCs. So essentially they can hide their operations using equipment, which historically a lot of, you would look at it as like owner operators, they don't want to put security solutions between their PLCs, or they don't want to put a lot of monitoring between there, because it's a kind of an implicit trust that there's not really anything out there that really gets onto a PLC and uses that as a function. And so one of the ways that this adversary kind of abused that kind of implicit trust is using our own, or using the Modbus and these other ICS specific protocols to evade security solutions, either by using or abusing the implicit kind of trust by bypassing firewalls, because you don't want to block ICS protocols, as well as using those to cover their lateral movement or to their kind of general operations, whatever they're doing. All right, so this is kind of like the example of what I was talking about, where you see this capability in action. They will perform enumeration using code assist. Once they identify an active PLC, they can actually kick off a operator and be able to basically sniff or read the traffic when the operator logs back in and capture credentials, which they can, the adversary operator can then use to log onto the PLC and act as that operator, or as the victim operator. Now, we look at, this is Bad Omen. This is the one that targets Omron, and it has the ability to essentially use a Omron proprietary ICS protocol called FINS, as well as a HTTP API that Omron uses. And this is like a good example of a fully realized attack suite against a specific PLC. It gives you a variety of methods to actually access the PLC. It performs exploits against the PLC that would allow access, such as by forcing on the telnet connection. It allows the adversary operator to automate enumerating what's on the PLC, to upload, download, and execute files on the PLC. So that's a lot of pretty much the bread and butter of what an adversary wants to do. Now, this also has similarities to Evil Scholar, in which case it can perform a denial of service, it can terminate active connections, it can use proprietary protocols. So like Evil Scholar used a net managed service that's a Schneider Electric kind of proprietary service. This one also uses the FINS protocol, which is, again, what I said, a proprietary protocol for Omron to perform reconnaissance and identify other Omron devices. Now, a very interesting thing about this is that the adversary actually brought in additional additional capabilities, such as using basically a way to sniff traffic from the PLC. So they brought a capability that would allow them to, it's TCP dump, to basically get on the actual PLC and just sit there and see how the network is operating, what this talks to, and be able to take that information and exfiltrate it to actually understand how that ICS network functions. Now, another interesting thing is that they also built in the ability to, one, manipulate servos, as you can see on the diagram on the left. This kind of indicates that the adversary was possibly testing to target against a specific victim or against a specific victim technology stack. And another interesting thing is that they also included the ability to actually wipe the PLCs. So whether this is to cause disruptions or to cover their tracks after they cause an impact somewhere else in the network, it does show that the adversary found novel ways to attack PLCs. So we look at Mousehole. Mousehole is the OPC UA kind of capability. It can scan for and identify other OPC UA servers or devices on the network. It does have the ability to brute force OPC UA passwords, as well as the ability to basically perform, I guess, a dictionary attack, or allow the adversary, if they somehow find credentials, to provide the credentials themselves. And one of the interesting things is that, as Michael previously talked about, inside of the history of ICS malware, there was crash override, which was a unique attack that utilized what's called OPC-DA. It's an older protocol, and that's how crash override or Indestroyer 2 even utilized that protocol. Well, this adversary actually took that attack methodology and improved it and made it a better implementation that they can produce at scale. So they took an attack that was very manual on the part of the adversary with crash override and Indestroyer 2, and increased the ability for the at which the adversary can scale that attack. So that's a very, very interesting thing, is that a completely separate group actually took another group's methodology and improved it and made it better, especially within utilizing ICS protocols, which are not very easy to understand. Now, a lot of times when we look at what the implications are behind an adversary like this, we want to kind of look at it as this adversary took the time to understand what happens with ICS protocols, how to achieve specific effects utilizing these protocols, that they more than, or I would say highly likely, had these devices themselves to test on and to develop these capabilities, which indicates that not only do they have a budget to get these, but that they have the supply chain established to get these covertly or clandestinely, whichever one is the more correct terminology there. But that kind of indicates that there is a well-funded, well-organized, and well-constructed. This isn't ransomware. This isn't a kind of, I'm not going to say unprofessional, but a novice kind of group. Like there is definitely knowledge behind this, and with the resources that they have, that these capabilities could not only be proliferated across more than one kind of a attack group, but that they can continuously be improved upon. And that's kind of the most concerning thing, is that if they can do it for just these two sets or these two sets of PLCs, and then this one with OPC-UA, this one protocol, that they can take that knowledge and expand it and start targeting more and more devices. And kind of what happens if these capabilities actually get out into the wild and lesser adversaries get the bar lowered for them to target with these capabilities.
So, Casey, you talked about the concerns about Pipedream. Talk about this. What should OT security teams be doing to defend against Pipedream and the concerns you've expressed?
I'll take that one, Tom. So we have some recommendations based on Evil Scholar, Bad Omen, and Mousehole, the three ICS components of the Pipedream framework. I'll talk first about Schneider Electric and Evil Scholar. So first off, the obvious one here is to change default credentials to utilize a complex password, right? A lot of these devices use default credentials of administrator. These should be changed to a complex password using the EcoStructure software. Also, disabling the Schneider Net Managed Discovery service, as Evil Scholar actually uses this to do some of that PLC discovery that Casey talked about for Evil Scholar. And on that sort of that same front, monitoring impacted PLCs for new outbound connections is really important here as well. For Omron and Bad Omen, restricting some access here. So restricting access to TCP port 80, TCP port 9600, and UDP port 9600. You only want to allow EWS systems to communicate on these ports, and you want to make sure that you have monitoring implemented there as well. And validating the engineering workstation software for Omron Sysmac configurator, and removing unnecessary software here that may make outbound network connections is really important as well. And then finally, for OPC-UA and Mousehole, ensure OPC-UA is configured with a security profile and authentication keys. You want to make sure that passwords for this are kept really secure. You may have to reconfigure OPC-UA devices to actually make use of the security profile and to actually sign a certificate here. And you should also consider disabling OPC-UA discovery features to sort of help in reducing your overall attack surface.
Beautiful, because it does beg the question, what are other threat groups that you're watching now that are targeting oil and gas?
So when we look at different threat groups that are targeting ONG, a lot goes into that. One is kind of what segment are they targeting? Are they targeting a specific geographic area? Is there are they actually targeting the OT sections, or are they actually going after just the IT network? And kind of that's what limits the adversary. We look at that as kind of like within the ICS kill chain, as you would say. Stage one is like the traditional Lockheed Martin kill chain, where it's purely kind of focused on the IT network. While if we look at the stage two within the OT or the ICS kill chain, a lot of it is the adversary, one, developing knowledge of what's going on with ICS networks, as well as like protocols. So they have to understand what's happening. They have to then take that understanding and develop new tools. And then they have to then implement that attack. So when we look at the threat groups targeting it, we can look at here, Parasite, which is what we would call a stage one. They target ICS organizations, but they have yet to actually access OT, the OT part of the network, as well as to develop capabilities specific to ICS or OT processes. Now we look at a good example is Dimaloy and Vanadinite, where they're able to access the OT network and they perform actions within the OT network, such as stealing configuration data. As we saw with like the malware, they were able to abscond with like ICS schematics as well as configuration information and Vanadinite, where they specifically went after kind of renewables within to like understand what was going on. So that's kind of like a difference in that they knew how to move and where the data was and how to actually identify what was important within the ICS network and then take off with it. And then we go to groups like Comosite and Xenotime and Chernovite, where they actually cause impact. So we can see kind of the full realization of these groups. Now, talking about Xenotime, a lot of these, what this adversary targets is essentially upstream sites, LNG production and transportation, as well as midstream gas pipelines. A lot of their activity is focused on recon and research on US-based ONG and LNG facilities. They have performed extensive research, and it is our assessment that that's kind of their overall intent is to target LNG compressor trains and terminal transfer points at LNG facilities. Most likely for a loss, kind of a focus on loss of containment. For like you would say an ecological impact, we'd like to say loss of the loss of containment itself. Whether it causes an ecological impact would be good for them, but overall that they just kind of want to create that loss or that loss of control that leads to the loss of containment. And now we look at Comosite. Comosite is the group that has done in destroyer or crash override in destroyer 2, as well as they have actually performed other far-ranging impacts, such as like impacting or infecting perimeter devices such as routers, IIoT devices. They specifically have an interest in LNG generation, as well as some others that are kind of like secondary or tertiary that ONG may interact with. So like you look at LNG electric generation, as well as the midstream pipeline that leads to that typically, and also minerals and mining, where that can heavily impact production and exploration. Now, recent activity includes Cyclops Link, what was detailed by the NCSC in the UK. They've also were responsible for the Destroyer 2 attack recently, and disruption across both Ukrainian power as well as like satellite communications.
And another one that's kind of a little bit more fringe is than Vanadinite. So their focus has been more on renewables and less on traditional oil and gas. But because a lot of oil and gas entities are moving into the renewables business, they're one that we kind of recommend focus on here. They're less stage 2 of the kill chain. They're more focused on intellectual property theft and operations specifications for renewable sites. A big thing we're assuming here is that joint ventures could be a potential risk center here. So looking into where you have joint ventures in foreign nations is a good place to start for Vanadinite. As far as recent activities concerned, we've seen them exploiting remote access vulnerabilities a lot in the past few years, and there's been some recent operations where they've focused on reconnaissance of North American energy organizations and operations for living off of the land in energy organizations as well.
Now that you've talked about the threat groups that are targeting oil and gas, talk about the different risks that could be facing upstream, midstream, downstream segments.
So when we look at the different segments, each one of those not only poses a challenge for organizations in securing it, but it also poses a challenge for like adversaries themselves. A lot of what we've seen has been focused mainly on downstream, such as with Xenotime, where they attacked a petrochemical facility in the Middle East. It was specifically targeted at a downstream facility, while it took that adversary a very long time and a large expenditure of resources to get to the point to where they could conduct an attack. You can look at midstream and upstream as kind of a, I would say not exponential, but a vastly more complicated target, as well as one that would require a far greater expenditure of resources than even what was conducted for downstream, due to one, a lot of these systems are very remote, and the places that they connect to are not the most easily accessible. It would take the adversary a lot longer to develop capabilities that would target kind of upstream. So you want to look at kind of remote production sites. A lot of those have a lot more manual control, so it would be a lot harder for them to attack the automated processes, as well as midstream, where it's heavily monitored. And not only that, it is heavily monitored, there's a lot more control that operators would have, especially along the entire line of, like, let's say a pipeline, or with maritime, that once it gets to a certain point, the adversary loses a lot of options and abilities to target those. But there are other places that they can target. So like upstream and even midstream, we want to look at utilizing vendors or organizations that do support to ONG, that fulfill specific tasks and would have specific access to sensitive processes. A lot of that you would see like either in monitoring or in kind of the, I guess, maintenance of these, such as like going out, ensuring that configuration files are correct or anything like that. And that's where a lot of the kind of concern comes in, is that are organizations doing proper validation on the vendors that are supporting them? Are they also ensuring that they're performing the correct access, that an adversary cannot utilize that trust relationship between vendor and the customer organization to manipulate processes or gain access to the OT environment? And so that's the primary that's primarily the segments that are probably the most at risk for upstream and midstream, while downstream has a far greater kind of threat surface due to its static nature and its ability to need to be more networked due to either the refining going on or the output from the processes needing to be monitored, and either going to distribution or to storage. And so that's where you would see a lot more of an adversary having the ability to interact with those kind of facilities.
So you shared a lot here. I wonder if I can ask the two of you, given everything we've talked about, what are your recommendations for what OT teams can do to improve their cybersecurity posture?
Yeah, sure, Tom. We could probably do an entire webinar just on recommendations here, but we have some on the slide sort of in context of Chernovite and Pipedream, which is kind of one of the most concerning threats of recent note, right? So one of the big things here is monitor east-west ICS networks with ICS protocol-aware technologies. A lot of what we talked about today from a Pipedream perspective is PLC communication to other PLCs. So looking for that kind of east-west communication, looking for modifications to PLCs occurring outside of maintenance periods. Security teams should be working really closely with OT teams to understand what those maintenance periods are and understand when there may be modifications to those OT devices. Conducting network telemetry analysis, right? Visibility. Looking for non-standard workstations or accounts to identify unusual interaction with PLCs. You really need that kind of visibility in the OT environment to be postured against a threat like this. Network isolation of safety systems. Monitor safety systems networks for new connections or devices and verify that configuration changes comply with change management procedures. Once again, understanding what maintenance periods look like, what change management procedures look like, and doing that validation as you see that kind of activity. And then isolating mission critical SCID systems. So consider implementing hardwired INO devices between critical SCID systems and distributed control systems in place of direct communications if feasible. Like I said, there's dozens and dozens of recommendations that we could go into, but in the context of Pipedream and Chernovite and kind of the most recent high visibility threat that we have today, these are kind of what we wanted to make sure we got out to the audience today.
Terrific. Michael, Casey, we have the opportunity to take some questions from our attendees. Are you ready to take some of those?
Yeah, happy to do so, Tom.
Excellent. We're reminded to our attendees as well, if you have questions you've not submitted, you still can. Might not get to all of them, but those questions we can answer in the course of today's session. We'll get responses back to you via email. First question, gentlemen. How can I manage the risk associated with allowing third parties, my vendors, my suppliers, et cetera, into my OT network? Again, that could be another whole webinar.
Yeah, absolutely. Good question, Tom. I'll take that one, Casey. First and foremost is not going to be anything that surprises anyone here, but enable MFA, right? We have seen organizations today that still allow vendors remote access with no multi-factor authentication. And kind of along those same lines, monitoring that remote access. Make sure that you have visibility into that remote access. Make sure that you have the ability to monitor and alert on that remote access, and make sure that you understand what that remote access should look like from vendors during specific maintenance periods, et cetera. Another thing is clean device policy, right? So requiring vendors that come on site to have scans of their devices or to have a corporate image that they should be using when they access OT environments, that kind of thing. Yeah, like you said, Tom, probably an opportunity for an entire webinar there, but probably some good high-level points there.
Next question, gentlemen. You've talked a lot about how extensible this framework is. Do you expect to see updates that add functionality?
Yeah, with the Pipedream framework, I would say that given the amount of development for just 2 of these PLCs and the demonstrated ability for the adversary to create these capabilities, that it's certainly more than likely that the adversary would explore targeting other PLCs, as well as looking at other ICS specific protocols to utilize, and maybe even getting into more kind of, once a general understanding or general framework is built, so develop a capability, they kind of create their own playbook for this is how we can create a tool that conducts everything that we need to cause a specific impact. And then all they have to do is fill in their knowledge, and with enough resources and time, they can then take what we see with like Evil Scholar and Bad Omen and transplant that over. And it'll become just easier and easier, and they'll start building that institutional or foundational knowledge that will just create a far greater threat surface. Because right now, I would say that even with these capabilities, that the threat surface for PLCs themselves are going to be a lot lower than you would see with like an engineering workstation, which would have a lot higher because of how much stuff can be interacted with it on it. But because we're seeing these capabilities now, especially the ICS ones, where they're starting to get more complex, more well thought out, and actually fully explored by adversaries, we can definitely say that more than likely in the future, there will be, it may not be this specific adversary, but there most likely will be an adversary that attempts to copy what this adversary did and port it over to a different kind of PLC device or ICS protocol to take advantage of. Because in these kinds of situations, it's about understanding what they want to target and who they're going to target, and then designing the capability around that, instead of that's kind of like how it was done in the past, and now these are starting to becoming a lot more generalized, so that they don't have to spend a lot of time understanding the victim network. They just have to get an idea of what's there, and then they'll have a selection of capabilities to deploy against them.
So, Casey, I had a follow-up question, which is, are other PLCs vulnerable to Pipedream? Have you covered everything you want to cover for that?
Yeah, for the most part, I would say that based upon the protocols that the adversary, the kind of the capability that the adversary created, it would be more than likely that it could impact other PLCs. It's just how they're going to manipulate it. It would be different based upon like how Omron treats it and Schneider Electric treats it with their ICS protocols, or even the OPC-UA. So we look at the OPC-UA where that can impact a far broader than just, let's say, Omron's. And then Code Assist is used in a lot, but again, it's how it's implemented with those devices.
Now, you said Pipedream has Windows modules. Do you expect to see this occurring frequently in IT Windows assets acting as engineering workstations?
Yep. They did build in capabilities to interact with what's more commonly engineering workstations are more Windows based. And with those, you can start seeing that the adversary, if they did compromise an IT network, they can use the capabilities they've already developed to move into the OT and then immediately start performing operations from there, especially if they can kind of create a home base or like a point of control within the OT network on a Windows machine, whether it be a domain controller or a actual engineering workstation. They do have the capability to utilize a Windows base inside of an OT network to then pivot onto like the Linux based for the Schneider Electric or Omron.
Gentlemen, one last question for you. I know we had some summarized recommendations, but to go a little deeper, what does Dragos want to see critical infrastructure organizations doing in response to all these new sophisticated threats that we've talked about here today, especially?
So, kind of echoing what our CEO, Rob Emily, kind of reinforces is that, one, you want to prepare for these eventualities of an adversary causing an impact. So you want to have an ICS specific incident response plan. Don't treat it as just an IT kind of incident response. You want to have the ability to, one, understand what's happening with the ICS protocols, as well as looking at not just, so as an anecdote, when Trisis happened, the adversary had multiple attempts to cause a physical, or essentially they were able to conduct the attack multiple times because cyber, a part of the incident response, cyber wasn't a part of it. They just thought it was like a mechanical error. So that really highlights, when we look at it, thinking not only like could it become a mechanical failure or a human error, that there could be a component of cyber involved, and to incorporate that into any kind of disruption or kind of anomaly within a ICS network. And now we also look at creating defensible architecture. So Michael touched on doing MFA. That's just like one part of it. The other part of defensible infrastructure is having visibility, is ensuring that you are accounting for not only adversaries kind of targeting the actual like a system itself. So like that's like vuln management, like taking care of vuln management would be one aspect. The other is actually like not allowing an adversary to use your own network policies against you. So don't be overly lax with security controls, do understand what's going on in your network, being able to do asset identification, having proper segmentation, or knowing who has access to what. It's one of the more important things, is knowing who exactly should be accessing what and being able to look at that and query it and identify it. We also kind of look at, as I touched upon earlier, network monitoring, specifically in the ICS, not just knowing where your assets are, but being able to actively identify and find assets, being able to identify vulnerabilities for ICS specific assets, knowing how to interpret and identify ICS protocols that are happening. Because if you don't know what normal looks like, how are you going to identify what maliciousness looks like? And that takes at first understanding what your ICS protocols on your network look like. Data collection and kind of aggregating logs within the ICS network is also probably one of the most important things, as well as really supporting root cause analysis when an incident occurs or an outage happens, and being able to make sure that you actually incorporate, as I said before, cyber as an element into that investigation. And probably one of the more common ways that adversaries access networks, especially ICS networks, is via remote access. And as Michael also touched upon earlier, securing that remote access, having even basic 2FA will deter a large majority of adversaries, both criminal and espionage. And then also ensuring that the remote access is monitored, and also kind of what we saw with like the Fortinet vulnerabilities or the F5 vulnerabilities or anything like that. Ones that, or Pulse Secure vulnerabilities, ones that allow an adversary to perform remote exploitation that you may not know occurring unless you have visibility into that remote access. And then again, probably one of the most important things, it's one reason that Dragos has like a vulnerability research team, is being able to have an idea of what vulnerabilities exist on your ICS specific equipment, and then being able to manage those. And not only that, supporting your vulnerability teams so that they can make change while also taking, it's a lot of the building up redundancy into your ICS operations, that vulnerability management can actually perform its job to reduce your threat surface and not cost you operational time or cost you money, essentially, by having to do downtime because you have to patch or you have to address a critical vulnerability at the last minute. And that's also where defensible architecture comes in, where you may not be able to address that vulnerability then, but you can create your kind of defensible architecture to make it harder for an adversary to get to that vulnerability to exploit it, but also to kind of, if you know something's really vulnerable, knowing that it's there is probably the most important thing, and then monitoring that. So it kind of coalesces all into visibility, monitoring, asset management, asset identification, and also knowing how vulnerable you are and knowing where the vulnerabilities exist and how close those are to your crown jewels. The most important process is you can look at as like how far away is a critical vulnerability to impact that process, and gaining that understanding so that a new vulnerability comes out, you can look at it and be like, this doesn't impact us because we know what's in our network, or this does impact us, we need to initiate actions to address it.
Well said, Casey and Michael. Appreciate your time and insight today. Thank you for answering my questions as well as the questions from the attendees.
Thanks for having us on, Tom.
Yeah, thanks for having us.
I want to thank our attendees as well. We know you took time out of your day to attend this session. We're grateful for that. I do trust that the insight and the answers you received today will give your organization valuable information so you can be even better prepared to tackle the ICS and OT security issues we talked about here today. I look forward to seeing you again at an upcoming event. Until then, for Information Security Media Group, I'm Tom Field. Thank you for your time and attention today.